Welcome back, everyone. Excited to wrap up our three-part series today with a focus on really the whole process. What does schema-based instruction look like from start to finish? So yesterday we talked about phase one instruction, where we're really focused on helping students reason through the different problems and identify them as a problem within one of the schema categories, and then map information from the problem onto the diagram. Today, we're going to look at problems that do have missing information and work through the whole process all the way up through solving and checking. So we're going to return to the sample lesson that we didn't really have time to talk about yesterday first thing today. Then we'll go over phase two of the schema-based instruction process. And then before we wrap up, we'll do a quick overview of the multiplicative schemas. So we looked at the additive schemas. We've been focusing all of our examples on the combine or total additive schema, just for clarity and simplicity's sake. But I do want to make sure we get to look at the multiplicative schemas for the upper grade folks before we wrap it up. Okay, so I asked you at the end of our session yesterday to take a look at that sample lesson plan in the folder. It's this document. It's called SBI Example Lesson for Phase 1 of instruction. So hopefully you had a chance to look that over, but what I would like to do starting out now is go into breakout rooms and talk about this example lesson for a few minutes. I want you to focus on these questions. How does the teacher fade support during guided practice? So this is a full lesson plan. You'll see an opening, a model, guided practice, independent practice, and a lesson close. You can skim through the whole thing if you haven't already, but I want you to really focus your attention on the guided practice section of the lesson plan. So ask, how does the teacher fade support through guided practice? And how is the structure of the guided practice in the lesson similar to or different from the structure of guided practice you see in your curriculum program, lesson plans that you write, lesson plans that your partner writes, whatever you're typically doing for math instruction or seeing for math instruction. So again, I want you to open up this lesson, the example lesson plan from the folder, and then spend some time with your group talking over these two problems here. I'm going to go ahead and send us into breakout rooms to get this conversation started now. And I'll try to visit as many rooms as I can while we're chatting. All right, you should see invitations now. All right, so everyone is coming back from the breakout rooms. I hope you had good conversations. I just had a really nice conversation with one of the groups. And so I want to clarify really quickly, again, that the order of instruction, or the process that we're going to use, is to, for each schema, to first introduce the schema, get the graphic organizer, that FAIR model, filled out with students so they know what the definition of the schema is, they know what the graphic organizer and equation look like, they have those basic pieces. Then you move to phase 1 instruction, where you're really focusing on reasoning and just working with problems that don't have any missing information to process the problems and get the information from the problems mapped onto the graphic organizers. And then you move into phase 2 instruction, where you're doing the same work, but you're now working with problems that have missing information that students are being asked to solve for something. So once students are proficient at solving problems, then you're ready to move on and introduce the next schema. So it's a multi-step process. I'm gonna keep an eye on the chat here for a minute. I wanted to see if anyone wants to share anything about these questions on the PowerPoint. So thinking about the guided practice in that sample lesson plan, what did you notice about how the teacher is fading support through the TAR framework? And then how is the structure of that guided practice similar to or different from the structure of guided practice that you see in your curriculum program, or lessons that you're planning, or lessons that your partner is planning for math instruction? So any ideas you have about those questions that came up in discussion, I would love to see in the chat. I'm just going to keep an eye on that and get back to sharing my screen here. So Sandra says it reminds me of I do, we do, you do. Yes, yes, very similar framework. I do, we do, you do. I like the tell, ask, remind acronym, the TAR acronym, because it's really helpful to use that language in your prompts with students. So when you're starting tell prompts, I'm going to tell you how to do these problems as you work along with me. And then those.
You don't know how to use a different speaker?
I'm sorry, I
don't know how to use a different speaker.
So that language can really help with transitions. So I'm going to tell you what to do. We're going to do a few problems that way. Now I'm going to ask you some questions, and you're going to help the group figure out how we work through these problems. And then we transition to R for remind. Okay, now remember what we've been doing together. Try these problems on your own. So I like that that acronym helps with transition phrases and language for moving through the levels, the scaffolded levels of guided practice. But it is really similar to the idea of I do, we do, you do. So Cami says, related to Think Loud's teaching students what questions to ask themselves as they think through a problem. Yeah, that's really important. So within the levels of guided practice, the level of questioning changes, right? When we're doing tell, ask prompts, or really teacher guided prompts, our questions can be really basic, like we're asking about computation. When we move to ask, our questions are getting a little higher level, like what do we do next and why? And as we're asking those questions, we're modeling for students how do you use self-questioning? How should you be talking to yourself? What questions should you be asking yourself as you work through this process? Lots of modeling, lots of practice opportunities. Gradual release allows for teachers to know when students are ready to try their own, similar to strategic instruction models. Yep, yeah, really similar to the sim lessons as well. All right, so thank you everyone who just participated in the chat. And I overheard a great conversation in the rooms. Christine is also saying how to get students to switch from the two parts being given first and then the total to the total being given first and the parts. Oh, so yes, we didn't talk a lot about variations on the types of problems. So part of the goal of spending so much time on reasoning and talking through the problems is to help students manage those differences in problem format and structure. So when the numbers are presented, or the quantities in the problem are presented in different orders, like if we're given parts first and then total, or total first and then parts, when we're talking about the problem and reasoning through the problem, we're focusing on understanding what are the parts and what is the total, right? Regardless of the order they're presented in. But for some students who really, really struggle, those differences can be really challenging, present big challenges. So I would say if that's the students that you work with, if you think that
make it work.
As you change the problem structure, that's going to cause a lot of trouble for anybody that you're working with. You can be really strategic and planful about that by just presenting problems with the parts coming first and then the total presented. Then introduce problems where the total comes first and then the parts are presented. And then introduce problems where you've got a part, then the total, then a part. And just really systematically work through all the different combinations or ways that those problems can be presented. Okay, so let's keep moving here. I'm really glad we got to have that discussion about the sample lesson plan. Today, we're going to focus on the whole process. So like I've been saying, so far, we focused on phase 1, where you're introducing the schema and then you're working on reasoning with problems that have no missing information. Today, we're going to look at the whole process where we're adding on problems that do have missing information. So again, here is the whole process. In the first step, you're using the attack strategy to process the problem. In the second step, you are labeling the parts and mapping that information onto the graphic organizer. In the third step, you're choosing a solution strategy. In the fourth step, you're writing an equation and solving. And then in the fifth step, you're going to check your work. So the first step, again, is use the attack strategy. So this is an example problem. We're going to use the run attack strategy to read the problem, retell it in our own words, and underline the question. So here's another example problem that fits into the combine or total schema. Ezekiel swam 15 laps at swim practice in the morning. Then he swam another 20 laps for extra training in the evening. How many laps did Ezekiel swim in all? So if we are using the run attack strategy, we're going to read that problem, have students read it with us. Then we're going to ask, we're going to retell it. We can model that or ask someone to help us with it. So in this case, this is a problem about a kid named Ezekiel. He's a swimmer. He does some swimming at practice in the morning, and then he does more swimming in the afternoon to do some extra training. And the question's asking us, how much did he swim altogether? Our question that we're going to underline is how many laps did Ezekiel swim in all? And then our final step of the run attack strategy is to name the problem type. I know that this is a combine or a total problem because we have the laps that Ezekiel swam in the morning, that's one part. The laps that Ezekiel swam in the afternoon, that's the second part. And then the question is asking us, how many laps did he swim altogether? That's our total. All right, then our second step, after we use the attack strategy, is to label the parts in the problem and map that information onto the schema diagram. So we're looking at the same problem here. Now we're just going to talk through again, what are the parts? What is the total here? This is a combined problem or total problem. So I know I have two parts that we put together for the total. The total is the number of laps Ezekiel swam all together. So we don't know how many that is. That's what we're going to solve for. But we're going to label that, how many laps did Ezekiel swim in all, as our total. And we're going to, this should be a question mark or a T. This is a little mistake on the slide that this is already filled in. But you could use the T or a question mark here to represent the missing total from the problem. Then we want to label our parts. So we've got two parts in this problem, the laps Ezekiel swam in the morning and the laps Ezekiel swam in the afternoon. So we're going to label the 15 laps that Ezekiel swam in the morning as part 1. And then we're going to transfer that information down into our diagram. 15 laps in the morning, that's part 1. And 20 laps in the evening is part 2. So I'm going to label it my problem and transfer that 20 laps into my diagram. So that's as far as we got yesterday, that part, those 2 parts of the process. Today we're moving on to phase 2 of instruction, again, where we've got problems that actually have a question in them, actually have some missing information, and we're going to finish the process. So now that we've got the information mapped into the diagram, we're going to choose the solution strategy, write an equation, check our work. So the solution strategies for all of the additive schemas are on these Frere models that I made for you all. They're in the bottom right-hand quadrant of the Frere models. And for some of the additive schemas, there's just one solution strategy listed. For others, there are 2 or 3 solution strategies listed. This is really up to your discretion as a teacher. What solution strategy do you want students to use to solve the type of problem that you're working on? What will be most efficient for them or easiest for them? In this case, combine total missing problems. Really, we're just adding the parts to find the total. So in this case, this is just abstract addition. 4 + 5 = 9. You could, if you had students that were going to struggle at this level, you could use counters as your strategy for adding, rather than just adding the abstract numbers and just using numbers and symbols. That's up to you. So the solution strategies are flexible. Use what makes sense, or what you want students to work on here. In this case, our solution strategy is just to add the parts to find the total. Again, for the additive schemas, some of the strategies are a little bit more complex. Some are simpler. But really, what you ultimately decide to teach your students to use is up to you. So in this case, again, our solution strategies add the parts to find the total. So what we're doing here, again, revisiting this problem about Ezekiel, is just adding 15 plus 20. And again, you can teach students to add the parts however you want to. The quantities in these problems, you can be really strategic in writing problems that use smaller quantities for students who have trouble with computation. The computation shouldn't be so challenging that it distracts students' attention and focus away from reasoning through the problem, right? Ultimately, the computation is not the point of solving word problems. Being able to reason through the problem, set up an equation, and solve is really the goal. So you can use, and with younger students, of course, you're going to use much smaller quantities. But I would say if you're working with older students who struggle with word problems, start with really simple quantities. This problem could be Ezekiel swam 1 lap in the morning and 2 laps in the afternoon. So that focusing on the computation, we just take it off the table. And struggling with computation, we can just take that off the table. And then you build up. Eventually you do want students to be able to do the computation at grade level, but that's not necessarily, we want to meet everybody where they are to start. And especially with word problems where there are so many more elements that are challenging. All right, so we're adding parts to find the total here. In our next step, we write an equation and solve. So we can start with the equation that matches our graphic organizer. Part 1 plus part 2 equals total. And then we can use our graphic organizer to write this equation. Part 1 is 15 plus part 2 is 20 equals total. We still don't know. right? And then we do our computation to find 15 plus 20 is 35. And then our final step always is check your work. We want to make sure we always have students check work. So again, the strategy that you teach students or you want students to use to check their work is up to you. That's really flexible. Here, we're just using subtraction to check our addition. So 35 was our total. If we take our total and subtract one of our parts, we should get the other part as our difference. You could use that strategy. You could use another one to check work. It's again, that piece is really flexible. We just want to make sure that we include check your work as a final step. Okay, so I wanted to just revisit this graphic again really quickly. We've just seen, so we just did a really quick overview. What does the whole process look like when we're using schema-based instruction? And we talked really briefly earlier about what does the process look like over time. So I just want to reiterate that here. Again, this is an example of a schedule that you might use if you were introducing schema-based instruction to teach additive word problems as initial instruction with younger students or as remediation with older students, either way. This is a 16-week schedule where you're going to teach all 3 additive schemas, and you're going to dedicate several weeks to covering each schema. So the first 2 weeks in this example schedule are just working on pre-skills to get ready. So working on addition and subtraction computation skills, working on solving equations, working on labeling charts and graphs. All of these little pieces that are pre-skills that students need to be successful with the word problem instruction. Then when you feel like students have a handle on those pre-skills, you're going to jump into the schema-based instruction. Teach the attack strategy and start with total unknown combine problems. Again, combine of the 3 additive schemas, combine is the simplest and is typically the one we recommend you start with. So starting with total unknown problems, spending about a week on those, working through phase 1 and phase 2 instruction. So you could spend one day teaching the attack strategy, say Monday. Tuesday, you review the attack strategy and start filling out the Frere model for combined total problems. Wednesday, review your Frere model, review your attack strategy, and start reasoning through combined total missing problems that have no missing information. Do more reasoning on Thursday, and then maybe on Friday, you introduce problems that have missing information. So you're just really slowly moving through the phases. So you've got a second week of total unknown problems, then you're introducing part unknown problems, then you're potentially introducing problems with 3 or more parts if you're working with older students. And then after 6 weeks of combined instruction, combine or total problem instruction, you're going to then move and introduce compare problems. So you see, you've got a lot of time for each schema. The reasoning is really challenging. It takes a lot of time for a lot of students to get competent with this. And you're giving yourself so much time because you're spending a lot of time helping students retell problems in their own words. In addition to being able to retell, then we're identifying what are the parts and what is the total. And that work can take a lot of time and a lot of practice. So combine, we introduce first, then compare is second, and change is third. Compare tends to be the most challenging of the 3 additive schemas. So we've got the most time in this example schedule dedicated to compare problems. So I see Marjorie said, I'd love to see a problem with 3 or more parts. So a problem with 3 or more parts might be, if we go back to that example about Ezekiel, it might be like on Monday, Ezekiel swam 15 laps at practice. On Tuesday, he swam 25 laps at practice. And on Wednesday, he swam 10 laps at practice. How many laps did he swim in all? So it's still a total missing problem, but we've got 3 parts. How many laps he swam on Monday, Tuesday, and Wednesday to add. When you are introducing problems with 3 or more parts, you just adjust your graphic organizer. So you've got a box for P1, a box for P2, a box for P3, and then a box for total. You can just add on boxes for the additional parts as you're adding those into the problems. Okay, so again, students are going to need a lot of practice in each phase of instruction to learn to solve problems accurately. So what I wanted to do at this point is give you some practice in working through the entire process for some problems that you write yourself. So I'm going to put you into smaller groups, 2 or 3 people in a group, and ask you to work together to write some combined total missing problems. Or if you're sick of talking about combined total missing problems, those are the simplest ones. Maybe you want to shake it up, challenge, do something a little more challenging. You can choose any of the other additive schemas. But write, each person in your group, work together, write a problem for each of you that fits into the schema that you choose. And then take turns modeling the whole process. So model the whole, and the whole process again is represented in this graphic. So walk your students, your other 2 partners in your group, through your attack strategy. Walk them through labeling the parts and mapping that information onto the diagram. Walk them through choosing a solution strategy, writing an equation to solve, and checking your work. So just to give you practice and give you an experience of going through the entire process. Then after everybody has a turn to model a problem, take a few minutes to debrief. How did it go? What went well? What could be improved? And then you can also start to think about these questions. What do you think of this whole process? Can you see yourself using it with your students? What do you think some possible roadblocks that might come up could be? What resources do you think you would need to do this effectively with your students? What questions do you have? So just think through, after you have a chance to work through an entire problem, think about these bigger questions so that we can come back and I can answer some of these for you or talk through some of these with you in the chat when we come back. So again, you're working through the whole process for problems that you write yourself. You can keep working with the combined total missing problems, or you can choose any of the other additive schemas that you'd like to play around with a little bit. So, okay, so I see, before we go, I see Gaynell wrote, sometimes students are also being challenged to solve word problems that are not only multi-step, they may include fractions, decimals, etc. Yeah, problems that involve fractions and decimals can also fall into these additive schemas, right? We're just using addition or subtraction to compute using fraction quantities or decimal quantities. So just because the problems involve fractions or decimals doesn't necessarily mean they're different, you need different schemas. They could fit into the additive schemas. They could also fit into the multiplicative schemas, which we're gonna hopefully have some time to run through before we wrap up today. There are also a set of schemas that are specially designed to work with ratio, rate, and proportion problems, which you're getting into a little bit by the end of elementary school, but those are really more meant for middle school students. But hopefully we'll get to touch on all of that when we look at the multiplicative schemas. So right now I'm going to send you back into breakout rooms with 1 or 2 other partners to write some problems and then practice working through the whole SBI process. All right, so everybody is coming back into the main room now after having an opportunity to work through an example problem through the entire process. And I got to join a couple of rooms this time. I, again, heard some like really interesting conversation about the SBI process and some issues that might come up. So I wanted to just continue the conversation there for a minute or two here. I'll watch the chat. What I'm really interested in is hearing your thoughts about using this strategy with your own students. What barriers or roadblocks you think might come up, what could be difficult about this, what resources you think you might need, questions you have. So again, I'll just watch the chat for a minute to see what you're thinking about all of those questions. All right, so I see Gaynell says, I'd appreciate guidance about how you'd move from one schema type to another in a multi-step problem. Right, so sometimes with the basic additive schemas, typically using one schema diagram is going to be enough to solve. But as you move into upper grades, you might have multiple parts of a problem that are going to require multiple steps and potentially different schema diagrams, right? So it's an added layer of complexity. I don't think I actually have any examples of that in any of the materials in the drive, but that's something that I can add in there for you as a reference for the future if that's something that you think would be helpful for your teaching. So someone says, it's interesting to point out to students the wording of the problem, underline what the problem is asking the student. Yeah, so again, like the main focus of this type of word problem instruction is on learning how to interpret the problem, how to reason through the problem, and to take the information from the problem, categorize it into one of these schemas, one of the categories, and then just use the strategies that go with that schema to solve. So really, like, focus is not on solving and checking. Focus is on all that sort of front-loaded work. I like this model for first kiddos, teaching them to label and actually understand the process beneficial. Yeah. How many slices of pizza were eaten and how many were left in a pie? Right. So multiple steps. Maybe you need to stack diagrams to solve. So here, I know, yeah, I understand. I can put some examples up. I think maybe I can get together an example lesson plan for multi-step problems like that to share in that Google folder. And then someone says, puts them in the driver's seat better. Right, which is the whole point, right? We want students to become independent. We want them to be able to solve these problems without a lot of support or handholding from us. We want them to get to that point. So the most important thing that we can do is help them figure out how to process the problem, how to interpret the problem. Okay, great. So again, we're running down on time for today. I don't think we're gonna have a ton of time to go over these multiplicative schemas, but I'll run through the slides really quick to show you the multiplicative schemas. And then if you have questions, if this is your areas, is what you're gonna be teaching, and you have some questions, you can feel free to shoot me an email and I'd be happy to email back and forth or even chat with you if that would be helpful. So the multiplicative schemas are the equal group schema, the compare schema, and proportions or ratios. There's another set that are just focused on rates, ratios, and proportions, like I mentioned. And if that would be helpful to have as a reference for anybody, like, shoot me an email and I'll share that with you too. I made another of these reference graphic organizers for you to have. This is in the drive as well. Again, with the definition of each of the multiplicative schemas, examples of each of the problem types, the equations, and the graphic organizers. And then there are slides here for each of the schemas and each of the problem types as examples. So I'm just going to run through these quickly to show you that they're here as a reference for you in the future, if these would be helpful for you. I also have a slide here that just has some links with additional resources that could be helpful to you if you want to start using schema-based instruction with your students. There are some sort of PD, professional development type resources here, and then also links for commercial products you can buy to help you get started with materials. And then also just some articles and books and things that you could read if you want a little bit more information. So today we looked at phase 2 instruction, or the whole process, and just a real quick run through those multiplicative schemas. Please feel free to reach out to me in the future. It's 2 o'clock, so I don't want to hold anyone, but I'll hang out for a few minutes to answer questions for anybody who has lingering questions.